Hello everyone, today we will discuss a medium hard level dynamic programming problem, LeetCode algorithm problem 213, house robber 2. We discussed the house robber problem yesterday, and the difference from house robber 2 and the original house robber is in original house robber problem, the houses are arranged in a line, but in house robber 2, the houses are arranged in a circle. Okay, so let's see our detailed description of this follow-up question, house robber 2. You are a professional robber planning to rob houses along street. Each house has a certain amount of money. All houses at this place are arranged in a circle. That means the first house is the neighbor of the last one. Meanwhile, adjacent houses has a security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. And we are giving an integer array nums representing the amount of money of each house. Return the maximum amount of money you can rob tonight without alerting the police. Okay, let's see. Firstly, let's see some corner cases. If there's no houses, then we just return 0. And if there's only one house, we return nums 0. And if there are two houses, we will return the larger one from the two houses. Then we will see our dynamic programming algorithm for the common cases for houses more than 3. We discussed the house robber problem before, which has line arrangement for houses, and the difference between this house robber 2 and the previous one is now houses are arranged in a circle. So how to deal with the new requirement? Actually, we can make two plans for the robber. So the first plan is to rob only from the first 3 houses, and the second plan is to rob from the last 3 houses. Because if we rob the first one, we cannot rob the last one. So for the first plan, we will omit the last one. And for the second one is if we rob the last one, we cannot consider the first one. So in the second plan, so for the second plan, we will omit the first house. And then for each plan, it transforms to the original house robber problem. And we can say, in general, if we have n houses, we make these 2 plans. The first one is to rob from house 1 until house n-1. N-1 is the last house. And then the second plan is to rob from the house 0, which is the leftmost house, until the house n-2, which is the second right house for the houses. And then we use our previous algorithm to solve the first plan, and use the algorithm again to solve the second plan. Then we will pick the larger one from these two plans, and to return the larger amount to the problem. Then we get the final best solution. Okay, let's see. Here we use 2 pointers, left pointer and rest pointer, and a temporary variable temp to store our results for smaller scale sub problems, instead of the entire DP array, including the n variables. Then we can save a lot of space. So in our original solution for the original house robber problem, we store a DP array, which has n scale. In that case, we have space complexity O(n), but now we only use 3 variables. So our new solution has better space complexity, which is O(1). Okay, let's see. So for our dynamic programming function, DPI, will calculate the largest money the robber can get between the leftmost house and the house I. So DPI should equal to the larger one between DPI minus 2 plus current house nums I and DPI minus 1, which is the adjacent left house. And this one is our best plan for the left from the leftmost house and the left of the left house, which is the house I minus 2 and plus the current I. From plus the money for the current house I, and we will omit the left house I minus 1. Okay, and instead of maintain a DP array for n length, we n here is like the n here is the length of the number list, length of nums, and instead of maintain a DP array as our previous algorithm, we just use the left pointer to store the best solution for DPI minus 2, and we use the right pointer to store the best solution for DPI minus 1, and then we calculate it. So for current DPI, we need to get the better one from DPI minus 2 plus nums I and DPI minus 1. So here we have current nums I plus left, because we use left to store DPI minus 2. And the other selection is right, which we store DPI minus 1. So the temp variable will store the current best solution for DPI. And then our right variable stores the DPI, the best solution for the leftmost house until the house I minus 1. So in this iteration, our left should move right, and then we have the value for the right variable to pass the value to left variable. So the left pointer will go right for one step, and then the right variable will store the current best one, which is temp. So the right pointer will go right for one stop. Then by iterations, we will get the final best solution from house 1 until house n minus 1, which is our first plan, robber 1, and the value is the value of the variable right. Then similarly for the second plan, between house 0 until house n minus 2, we have the for loop between house 0 and between house n minus 2. And then the logic is similarly as our previous one. And then the value for the second plan is the value of the right variable after the for loop. Then our final best solution is the larger one between the first plan robber 1 and the second plan robber 2. So we'll return max robber 1 and robber 2. Okay, let's submit our solution. Yeah, we can see the memory usage we less than 71% of other solutions, because we only have space complexity 01, and we use variables left, right, temp instead of the entire DP arrays of lesson. Yeah. And our time complexity is On, because we only have one layer for loop. Although we use for loops twice, but for each for loop, we only traverse the array once. And actually, the time complexity for the whole algorithm is the largest time complexity between loops. So the time complexity is On for the first for loop, and then the time complexity is On for the second for loop. And the larger one between the two is also On. So our time complexity is On here, and our space complexity is O1, because we only use variable left, right, temp to store the best results for sub problem of the entire dynamic programming problem. Instead of we maintain the whole DP array containing n variables. Yeah, that's why we have the space complexity O1. Yeah, that's all for today. Thank you so much for your time. Bye bye.